Okay. So there's two ways to do it. You could make it when you're drawing a molecule. Okay. Say, for example, you have something like this. You yourself figure out which atom has a formal charge of minus, and you can know which atom it is. Or you can calculate it. Okay? Say, for example, you have one of these ugly problems in the book. Ugly because they don't tell you where that formal charge is. They're just like, yep, it has a charge of minus. And they say, what is the formal charge of, the chlorine there or the iodine there? Okay? And you can calculate it. Now let me show you an easy way to calculate formal charges. The equation in the book is very difficult to use, and it's complicated and it's tricky and you'll make mistakes. Let's say you want to calculate the formal charge of this carbon in this molecule and this oxygen in this molecule. Okay? Now, if you have a drawing, what you want to do is add your dots on top of the line so you could actually picture them. Okay? And my formula looks like this. Formal charge is equal to the number of electrons an atom wants minus the number of electrons the atom owns. Okay? Now, the number of electrons that an atom wants is the group number, okay? That's the group number. It's not 8. Okay, it's the group number of the element. All right, so keep that in mind. And the number of electrons that something owns is going to be all the unshared, but half of the shared. And that kind of makes sense because, if you're sharing something, you technically only own half of it. So let me show you how to do it with carbon. So carbon, the formal charge for carbon is going to be equal to the number of electrons carbon normally wants. Carbon is going to be neutral when it has 4 electrons. So that's how many it wants to be neutral. It's the group number. Now, how many electrons does carbon own? We count half the bonds. So I use boxes rather than circles for this math. How many electrons are in that box? 4. So the formal charge of carbon is equal to 0. How about the formal charge of oxygen? Oxygen wants 6. It's in group 6 of the periodic table. To be neutral, it would want 6 electrons. Okay? How many electrons does the oxygen own? Count half the bonds and all of the dots on this atom. How many total electrons are in this box? 2, 4, 6, 7. 7. So 6 minus 7 is minus 1. So therefore, I can go in now and write minus on that oxygen atom. Okay? So the formal charge of carbon is 0. The formal charge of nitrogen is 1. Okay? Let's do another one using my method. So again, we're given this molecule here. Okay? Step 1, I suggest putting dots on top of each of these lines so that you could count things, okay? So the formal charge for carbon is going to be equal to how many, the group number for carbon, minus how many electrons it owns. So we count half the bonds and all the dots. So it's going to be -1. Oxygen, normally it's in group 6. How many does it own? 5. Okay, so carbon has a formal charge of -1. Oxygen has a formal charge of +1. Okay, let's do another one. Okay, so we're going to call this A, B, C, and D. Okay, so atom A is a chlorine atom. It's in group 7. Okay, and we count the number of dots on that chlorine and half the bonds. If you can't see the electrons in the bond, feel free to add 2 electrons on that line. Okay, inside the box there we have 7. So 7 minus 7 is 0. How about chlorine labeled B? Chlorine also wants 7, has 7, so it also has a charge of 0. How about chlorine labeled C? Chlorine wants 7 because it's in group 7 and it owns 7, so it's going to formally have a charge of 0. How about the bromine in the middle? This is bromine. Bromine also is in group 7 of the periodic table. So let's go ahead and carefully identify half the shared and all the dots left over on it. 1, 2, 3, 4, 5, 6, 7, 7. I was for sure thinking something would be plus or minus, weren't you? Okay. So that's basically where you're at, okay, in terms of looking at formal charge. And we'll stop the lecture there. I think we've covered enough of Lewis structures.